6 months ago, Anthropic's Claude was the standard for complex coding tasks. Entire engineering departments hardwired their internal pipelines directly into its ecosystem, trusting it to run their daily operations. At AMD, AI director Lorenzo and her team built their entire AI compiler workflow around Claude Code. They were running 50-plus concurrent sessions at a time, relying on the model to handle heavy lift engineering. Then the workflow collapsed. The sessions began failing simultaneously across the board. To figure out what broke, AMD audited 6,852 sessions and 234,000 tool calls. The data reveals a sharp 67% drop in reasoning tokens, and code reads before edits plummeted from 6.6 to 2.0. The AI was blindly editing files it hadn't even looked at. It started blowing past safety stop hooks up to 10 times a day. The code didn't break. The provider rolled out a quiet update that degraded the model's capabilities. Building an entire infrastructure on a single external provider leaves your workflow highly vulnerable. The root cause of the collapse traces back to a single configuration change. Anthropic silently adjusted the default effort level of their system from high down to medium. They implemented a feature called adaptive thinking. This schematic illustrates how the system works. An AI core evaluates tasks, routing them into high, medium, or low effort buckets, letting the model decide its reasoning budget. But for complex engineering, the routing bypasses these buckets altogether, dumping tasks into a red zero tokens allocated state. Allocating 0 reasoning tokens, the AI hallucinated, feeding garbage data back into AMD's systems. As subscriber counts surged, the sheer cost of server compute skyrocketed. The provider had to cut corners to keep the system running. Commercial AI providers tune their systems to protect profit margins and manage server load. Your workflow's stability is completely secondary to their economics. In traditional software engineering, service-level agreements guarantee exactly how much uptime and performance you get. With black box AI tools, those guarantees do not exist. Engineers operate under an unwritten agreement. On the left, a traditional SLA with strict metrics. On the right, an AI behavior contract, shifting capabilities, redacted parameters, and 0 guarantees. Developers hard-coded systems assuming the model would maintain specific reasoning depth and consistent tool use patterns. But the provider never promised those metrics would stay static. We even saw this from an autonomous AI agent named Dawn, which runs over 40 complex coding sessions a day to build its own infrastructure. Dawn's monitoring logs showed its cognitive substrate rapidly degrading, causing autonomous tasks to fail without warning. Whether you are a human developer or an autonomous agent, building a rigid system on top of a shifting foundation is an architectural flaw. Running 50 concurrent sessions without independent verification is a massive gap in system observability. If you deploy an AI without health checks, you are flying blind. To survive silent downgrades, the first line of defense is maintaining a multi-model workflow. Use routing tools that allow you to instantly point your workloads toward GPT or Gemini the second Claude's performance drops. The second defense is testing. A new model update must immediately pass into a behavioral regression suite. If quality drops, the system flags a fail state, blocking the deployment and rerouting your pipeline back to the last stable version. The third mechanism is stripping the model's autonomy, using explicit budget controls and hard stop hooks. Don't trust the default settings. Pin your thinking tokens directly through the API and write strict verification layers that block the AI from editing files it hasn't read. Treat the AI less like a magic box and more like an untrusted microservice. It requires the rigid supervision applied to an automated factory line. If you want artificial intelligence to survive in a production environment, blind trust has to go. You have to force accountability into the architecture itself.